Hello everyone, my name is Hemu. In today's, we are going to discuss life of a packet in PAN-OS or packet Palo Alto Firewall packet flow or life of a packet inside the Palo Alto Firewall, life of a packet inside the PAN-OS, right? Or the packet flow. These are the different terms used by the peoples for the same thing. Okay. So guys, to understand the Palo Alto Firewall packet flow, right? First, I will try to explain you the block diagram. What are the component we are having on an Palo Alto Firewall devices? Okay. So generally what used to happen in your Palo Alto Firewall, first, we have all the data ports. These are the data interfaces, Ethernet 1 by 1, Ethernet 1 by 2, Ethernet 1 by 3, 1 by 4, 5, 6, 7, and 8. Let's take an example. We are having a 8 data interfaces on my Palo Alto Firewall. So what used to happen, all these interfaces, they have a direct connectivity with one of the chip, which is known as Marvel chip or either the Petra chip. Now, this Marvel chip, when you have this Marvel chip, which means all your copper ports, they have a connectivity with the Marvel chip, and all your SFP ports or the fiber ports, they have a connectivity via Petra chip. Then this particular Marvel and Petra chip, it has a direct connectivity with one more chip inside the Palo Alto Firewall, which is known as Liger chip or the Tiger chip. Liger chip you will see in the low end boxes, and your high end boxes, they have a Tiger chip. And guys, this particular chip is known as network processor. This is the third component of your Palo Alto Firewall data plane, or the first component of your Palo Alto Firewall data plane, because Palo Alto Firewall data plane divided into three planes. We have a network processor, then we have a security processor or the data plane CPU, DP CPU, then we have a signature match processor or the pattern match processor, where we have a Ocelot or either the Jaguar chip. So all your layer 7 related tasks, which includes your app ID and your content ID, these tasks performed by the Jaguar chip or either the Ocelot chip. So in high-end boxes, you will see the Jaguar chip. So Jaguar is a chip who is responsible for app identification and content identification. And this Octeon chip, this is a main chip basically, or you can say this chip known as a security processor. And guys, your Palo Alto Firewall packet flow depends on this particular chip functionality. Your entire packet flow works till here. Means Octeon is a main chip inside your Palo Alto hardware appliance who will basically perform all the tasks according to the life of a packet. And you know, each of these chips, they have a connectivity with the high-end fiber links, and these links is known as joy links. So guys, this entire thing is known as data path. Means whenever we receive a packet, what your packet first enter inside Ethernet 1 by 1, so it will go into the Marble Petra chip. It will hand over this packet to Liger or Tiger chip. Then Liger and Tiger chip will hand over this packet to Octeon chip. Now this Octeon chip will start the packet processing. So it will process packet at Ingress Stage, Flow Lookup, Silo path, fast path, and if app ID and content ID needed, then what it will do, it will hand over the layer 7 information to this particular chip, and this particular chip do the app identification and content identification, and after that it will return the results here. Then this Octeon chip will do the egress stage or the forwarding of the packet. Now you may ask, because see, your ingress stage, flow lookup, slow path, fast path, and forwarding, these tasks done by the Octeon chip, and your app ID and content ID is done by the Jaguar chip. Then what is the use of this particular network processor? So guys, this network processor known as the session offloader. This is a session offloader. So tell me one thing, guys. Let's take an example. We are receiving lots of data, and that data is encrypted. Let's suppose we are receiving the encrypted data, and that data is encrypted by the TLS, transport layer security. TLS is also known as HTTPS or SSL. Tell me one thing. If we are receiving the encrypted data by the TLS protocol, because we are receiving this encrypted data, is my Jaguar chip able to inspect that data? It is not able to do that, right? Because we are receiving the encrypted data, and just suppose we are not having SSL decryption on the firewall. SSL decryption is off, means it is not configured. Then do you think these type of packets we can forward till here? It is not making any sense, because that data is encrypted and my Jaguar chip will not able to understand anything. So in that case, what used to happen whenever we will send these type of encrypted data to Jaguar chip? So what Jaguar chip will do, it will basically mark a session. Let's suppose session ID is 100 for this traffic. So it will mark layer 7 is completed. And when this particular flag added with this particular session, because session management done by the Octeon chip. So what it will do, this Octeon chip to offload the processing from here, it will just offload the load from this Octeon chip. It will just hand over this packet to the Tiger and Liger chip. And now this Liger and Tiger chip will do the Ingress Stage, flow lookup, fast path, and forwarding. Because this network processor is able to understand your layer 2 to layer 4 information. So means your Liger and Tiger chip only process the offloaded sessions. Just remember, it is a session offloader. And guys, this particular session offloader you will only see in high-end boxes like 3200 series, 3400 series, 5200 series, 5400 series, right? Or the 5000 series or the 7000 series boxes. Your low end boxes, they are not having such type of chips. Okay, let me just, for an example, let me just show you one more example here, because generally I used to cover that example in your, if I will go into your, 1 minute, into your this SP3, but because SP3 we have skipped for now. So I just wanted to show you one diagram of 5000 series box. So at least you will get the idea. Ultimately, I will come here again. If you will see this particular diagram, guys, it is visible to everyone, I hope. This is the block diagram of Palo Alto Firewall 5000 series box. Now, what used to happen? We have a switch fabric here where we have a Petra chip, right? And this Petra chip has a connectivity with the network processor, where we have a Tiger chip. This is known as data plane. Sorry, this is not known as data plane. Then we have a Octeon chip, and entire thing, your signature match processor, your Octeon chip, and your network processor, all three component is known as data plane, DPCPU, or the data plane of your Palo Alto firewall. Now, here if you will see, in the high-end boxes, we are not having one Octeon chip. We have here 3 Octeon chip, and it's a multi-core Octeon chip. It's a multi-core CPUs, right? We have a 3 CPUs. We have a 2 Jaguar chip here. See, signature match processor, where we have a Jaguar engine, or this is also known as signature match engine. And we have a security processor where we have a Octeon chip, and this is known as DPCP. So your entire packet flow done here. But now this chip will decide if layer 7 is not needed for some packets, then it will offload such type of packets to the network processor, and network processor will act as a session offloader, means it will process the offloaded session. And this particular processor is not available on each and every box, just remember. Okay, and we do have a management plane here which have a separate Intel core CPU. Okay, and I will come back again into this diagram, guys, one more time when we will discuss when I will basically explain you the SP3. As for now, let me just, guys, start my discussion by explaining this particular diagram. So guys, if you will not able to understand the session offloading, then you can skip. This will not ask by the interviewer because people is not aware about that one. These are the little bit advanced concept from the troubleshooting classes, but I am covering here. Okay, so if you are not able to get it, that is totally fine. Now, let me just start my packet flow. So guys, what used to happen? Let's take an example. Let's take an example. We have a PC here, PC1. We have a firewall here. This is a Palo Alto Firewall. Then let's suppose we have a one server here. And I'm just making a direct connection. This is Ethernet 1x2 interface. This is Ethernet 1x3 interface. This is inside. And this is DMZ. Now let's take an example. From this PC, I have initiated the connection toward this server. And this server having IP address 10.2.2.101. This PC have IP address 10.1.1.85. And let's suppose this server is hosting the service on TCP port 22. I'm running SHS services on it. Okay. Now let me just start how the things are happening basically. So what used to happen generally? Let's take an example. From this PC, I have initiated the packet. So this packet received by the firewall on Ethernet 1x1 interface, right? Means firewall received that particular packet. When it will receive that packet, what it will do? This particular packet, it will put into the Ingress processing. Where it will put? It will put this packet into the Ingress stage. I'm not able to manage the size properly. Oh, I'll use from here. Okay. On the browser, there are the issues. So, let's take an example. I have received that packet on Ethernet 1x2 interface. Now, when my firewall receive this packet, what it will do? It will put this particular packet into the Ingress stage, and which is a first stage of the firewall. It will put this packet into the Ingress stage processing. And after that, what it will do? Now it will basically start the packet processing at the Ingress stage level. And when your packet reaches at the Ingress stage, what it will do? The very first task it will perform. We have received the packet at the Ingress stage, right? So the very first task, what it will do? It will start the packet parsing. It will start the packet parsing. And your packet parsing, it will start from the layer 2. How it will start the packet parsing? It will start the packet parsing by reading the source MAC address and destination MAC address. So I can say by reading the Ethernet header. And from that Ethernet header, it will extract the layer 2 information from the packet, which is source MAC and destination MAC. And apart from that, it will also read some other information as well. And what are that information it will read? Let me open one more file, because that's the file which I have taken. running the flow basic commands on the Palo Alto Firewall, so you will get the idea. Right? So packet received at the ingress stage, and it has basically start processing this particular packet. It will assign one work queue index to this packet, right? This is some type of identifier for the processing. And after that, what it will do, it will start packet parsing, and it will start the parsing from layer 2. It will parse the packet, it will write down the layer 2 information, which is source MAC and destination MAC, and the ether type. Because your layer 2, or because your from the layer 2 header, your ether type will tells us the what is the next header we are expecting, right? Guys, how we will get, we are having the IPv4 or we are having the IPv6, because we have a ether type here, and this ether type tells my firewall next header you are expecting IPv4. So what it will do, now it will start the packet parsing at layer 3. And what it will do, when it will start the parsing of your IP header, it will write down the source IP address, destination IP address, layer 3 protocol number. What is the layer 3 protocol number? 6 for TCP packets, right? Guys, just write on the chat like this TCP protocol header or layer 3 protocol header, we have 6, which is a TCP, right? Then version, this is IPv4 version, this is header length, this is your type toss bits, right? If you have seen the IPv4 header, we have a toss bits, we have a length field, right? Then we have a ID, fragment offset, TTL, checksum. So what it will basically write all this information from the IPv4 packet. Then it will basically check the TCP header, and it will get the information from TCP header, which is source port, destination port, sequence number, acknowledgement number. And guys, always on the TCP SYN packet, we have a acknowledgement number, which is 0. Reverse field, offset, window size, checksum, flags. And guys, all very first packet is always a SYN packet, right? You can see the SYN packet, urgent data, and all these information. And for the TCP option fields, this is the TCP options field. So guys, what it will do, all these particular tasks. This is how it will start the parsing. But apart from that, because this particular log I have taken for a working scenario, so as I have mentioned, what it will do, it will start the parsing at layer 2. It will basically try to get the ingress port detail. Means when we receive a packet, we know we have received the packet on Ethernet 1x2 interface, right? So it will write down that ingress port detail. If we have configured the sub interfaces, then it will basically write down the 802.1q tag. Destination MAC address are used as a key to look up the ingress logical interface. Means if we have a sub interfaces, then it will utilize these values, your .1q tag, to get the sub interface detail. If the interface is not found, then the packet is discarded. The hardware interface counter increase by the receive error, or the global counter will increase with this error, flow receive.1q tag error. If there is any type of issues we are having with regards to the layer 2 parsing, then these are the counters it will increase, guys. And if I'm just running this command just for the knowledge purpose, because we will have a troubleshooting session, then that time I will help you. So counter global, if you run this command, we have all these particular counters, and it will increase these counters. If I will just match some error, I will type packet send error drop, right? These are the counters it will increase at the processing level. Even though if you will go here, if you will see, Hello receive dot one q error. If you will type this counter and you can match this value directly, just look for this counter. You can see this is the counter which will increase continuously if your packet is dropped due to that particular reason at the layer 2 parsing. And guys, in your traffic logs, you will not able to get if your packet is dropped due to that reason. And there is only one way to do the troubleshooting. You have to take the help of global counters. Without checking the global counters, you cannot able to do the troubleshooting. Just remember. Even though I am going to explain you these global counters again because we have a 255 plus global counters on the Palo Alto Firewall. Okay. And you know when it be now while doing the parsing, what it will get the next IP header. Now it will start the layer 3 parsing. And as I have mentioned, when it will start the layer 3 parsing, what it will do? IPv4 firewall will discard the packet for any of the following reasons. Any guys, when it will start the layer 3 packet processing, what it will do? It may discard the packet due to the mismatch of ether type and IP version. If there is any type of mismatch with regards to the ether type and the IP version, let's take an example. When we have processed layer 2 header, that time we have seen the ether type for IPv4, but in actual we have a packet with IPv6, which is wrong, right? So if there is a mismatch with regards to ether type, what it will do? It will discard that packet right away. If there is any type of issue with the truncated IP header, means see, in IP header it has a proper format, right? If there is any type of somebody has done any type of, if your IPv4 header is broke anywhere or truncated, what it will do? It will drop that packet because your IPv4 header must be according to the IP stack programming. Okay, otherwise your packet will be dropped by the firewall. If we are receiving IP protocol number which is 0, in that case also it will drop that packet. If we are receiving the packet with the TTL0, time to live, which is 0, then also it will drop that packet. And if we are suspecting land attack means source IP equals to destination IP. If this is the case, means source is similar and destination is also similar. Means somebody has done some type of modification on my IP header, right? So what it will do, it will basically drop these type of packets as well. Ping of death, martial IP address, and IP checksum errors. If there is any type of error with the checksum, so in such type of cases, your packet will be dropped by the Palo Alto firewall. Just remember. And for IPv6, mismatch of ether type, truncated IPv4 header, truncated IP packets, jumbo gram extension, or truncated extension field. If we will receive these packets, it will drop the IPv6 packets as well. Now next header it will look, let's take in our case, it's a TCP, right? So TCP packet, what it will do? It will discard these packets. If we are receiving TCP header is truncated, means somebody has modified the TCP header fields. Then it will, this type of packet is dropped. Data offset field is less than 5. Then also it will drop the packet. Checksum error, it will drop the packet. Port number is 0, then also it will drop the packet. An invalid combination of TCP flags. Guys, in case of TCP, do you see any type of packet with where you will see SYN flag equals to 1 and FIN flag is also equals to 1? It is possible. Is this combination is possible? It is not possible, right? So such type of packet is also dropped by the Palo Alto firewall if we have an invalid combination of TCP flags. For UDP, if UDP header is truncated, for UDP payload is truncated, and the checksum. If we have a problem with the checksum, then also it will drop the UDP packets. And guys, this particular thing, it will perform at the layer 2 parsing. at the parsing state at layer 2, layer 3, and layer 4. And if you will see here, even though all this information I have written here as well, right? So you can check out this information as well, right? You know, a packet is subject to firewall, then it will continue firewall inspection. Packet may be discarded due to protocol violation, right? So it will drop these packet. Your packet parsing is start from layer 2, layer 3, and layer 4 information is extracted, and ingress zone and ingress interface and zone lookup used to happen. Packet parsing at layer 2, layer 3, IPv4, IPv6, layer 4, and UDP, right? No. So as I mentioned, extract means it will do the parsing and it will extract the layer 2 information, layer 3 information, layer 4 information. And we know I'm just highlighting the main thing: source MAC, destination MAC at layer 2, at layer 3, source IP, destination IP, and layer 3 protocol number. And at your layer 4, source port and destination port fields. It will extract that information because we know it will perform the ingress interface and zone lookup. We know we have received the packet on Ethernet 1 by 2, and we know this Ethernet 1 by 2 is a part of inside zone, right? So it will get the zone details as well. And now, now guys, sometime what we used to happen, sometime we used to receive a fragmented packet. I hope you are aware about the fragmentation. If we have a packets with a higher size, then what will happen at layer 3? It will do the fragmentation. It will basically divide a very big packet into small packets. Because let's take an example. If we have a MTU of an interface which is 1500 bytes, then we can only able to send a packet with these particular size, 1500 bytes. If we have a packet more than that particular size, then your fragmentation will take place, and fragmentation will be performed by the firewall or by the routers, whatever the device we are having. And if we are receiving these fragmented packets, what it will do now? So to read the layer 3 and layer 4 information properly, because your fragmentation start from layer 3 onwards, what it needs to do, it will basically first to assemble all the fragments, and after it will make the proper layer 3 packet, and then only it will start the parsing. Just remember this part for the fragmented packets. See, IP fragment, IP fragment assembly if required. If fragments will be parsed, reassembled by the defragmentation process. So in your firewall, we have one process called defragmentation. It will basically do the IP assembly and it will fed back to the parser. Parsing will be continue with the layer 3 header onwards. Okay. And a fragment may be discarded due to tear down. A teardrop attack means there is a overlapping fragments, or if one of the fragments are missing, all the fragments will be dropped since packet cannot be reconstructed. Okay, just remember. So your fragmented packets may also drop due to the overlapping fragments or due to the missing fragments. If some of the if one of the fragments has been dropped due to any type of loss in your network, what will happen? My firewall or my device, it will not able to construct the entire IP header and it will not able to process it properly. Okay, so these packets also will be dropped by the firewall. Now guys, and after that what it will do, it will do the checks for ingress process error. Means ingress process error means what will happen when he has performed the parsing here, right? Now it has checked if there is any type of header errors are available. What it will do, if there is any errors, then it will basically discard that packet right away. If there is no ingress process error, because this particular task done at the ingress stage level, Then it will move further. It will check is this packet requires the firewall inspection? Yes. Then it move further and it will go for the IPsec or SSL tunnel packets. If your traffic belongs to IPsec or SSL VPNs, then what will happen? It will basically send this packet towards the tunnel decryption process. Because if we know that that's a VPN traffic, which is IPsec VPN or the global protect, then what it will do, this packet go through with the IPsec or SSL tunnel decryption. Means we will decrypt that packet and we will get the original packet, and after that we will basically do the packet ingress processing again on the actual IP headers. So guys, this is the ingress stage of your Palo Alto firewall. But because this diagram is a very old diagram, around 2010. So after that there is a hell lot of changes happens and we have a new diagram. And now let me just explain you according to the new diagram what are the tasks is happen. So guys, is my screen is visible and are you able to see this particular things properly, this ingress stage? Because I have to decrease the size a little bit, because this diagram I have created as per the latest PanOS processing. We have received a packet. We will check packet ingress process, extract layer 2, layer 3 and layer 4 information. When it will extract this information, it will do the ingress interface lookup. It will get the source zone details, fragmentation. It will perform the IP assembly if he received the fragment packets. Then it will go for the ingress process error. And after that, guys, in your new PanOS versions, they have introduced one more field called DOS block table. Let's take an example. You have configured zone protection and the DOS protection on the firewall. If you have configured these two features, and we know 192.168.1.70, this particular IP address is launching these particular flooding attack, maybe SYN flood attack or UDP flood attack or the ICMP flood attack, or he is doing the IP spoofing attack, right? If this particular from this IP we are getting these attack, what will happen? Such type of attack is basically detected by the zone protection, DOS protection, and what it will do, it will basically add that particular IP into this DOS block table. It is similar to the SAM database on checkpoint firewalls. And if this particular IP address available into this DOS block table, and if we have seen this IP address, what it will do, my firewall drop that packet right away. If yes, means your IP address belongs to this particular DOS block table, it will discard that packet. If no, then it will check is firewall inspection applicable or not. Now, how firewall inspection is applicable or not? So guys, in case of tap mode deployment of your Palo Alto firewall inspection is not required, because tap mode is just a alerting system. It acts as a IDS device. So if you will deploy your firewall in tap mode, then firewall inspection applicable no. So it will directly go into the egress stage. Otherwise, for all type of deployments, your firewall inspection is always applicable. Yes. Then it will go into the next check, and where it will check if packet belongs to the IPsec VPN, or either it is belongs to the SSH secure cell, or the SSL VPN, which is global protect, or the GRE tunnel, because these are the tunneling protocols, guys. IPsec, SSH, SSL VPN, and GRE tunnels. If your packets belongs to these particular tunnels, if yes, then what will happen in case of IPsec? In case of IPsec, all your packet is encapsulated inside the ESP header, guys. So who has not worked with the VPN? So ESP is a protocol who will basically hide the actual packet in your VPN communication. Okay, when we will discuss BPN, that time I will tell you more details about this ESP. So what used to happen if we have received this IPsec BPN, IPsec ESP packet, what it will do? It will perform the hash check, means it will check, it will basically create the hashing, it will generate the hash, and it will basically check that hash is matching or not to validate the integrity of the packet. Packet is not tampered by anyone in the path. After validating the integrity, means if hash check is passed, then it will do the decrypted. Now it will perform the decryption on the packet, and after that it will do the decapsulation. Once it will do the decapsulation, what we will get the actual IP header or the inner IP header, the actual source IP and destination IP. And after that, it will forward this particular packet to your Ingress processing again. In case of SSL VPN, first it will do the hash check, then it will decrypt it. Here decapsulation is not required, guys. Only it will decrypt because your packet is decrypted at the TLS by the TLS header, transport layer security. In case of GRE, it will do the hash check and it will do the decapsulation. Once he has the actual information, it will send that information to the Ingress processor or Ingress process. And guys, that's how your Ingress stage checks performed by the Palo Alto Firewall. And if everything went well, now it will move further towards the next check, which is a flow lookup. Now, let's try to understand this part, guys, here. When he has performed the extraction here, that time it has extracted the source IP address. Source IP address is 10.1.1.85. I am just following that diagram which we have designed. And destination IP was 10.2.2.101. Source port, random port, let me just use 3050, and destination port, let's suppose 22 for SHS, layer 3 protocol number, S6 for TCP, and source zone detail is inside. Now these are the information it has collected from here, right? In your Ingress stage. So what it will do, it will basically take all this information and it will basically run the MD5 hash. It will pass this information through the hashing function, which is MD5 hash, and it will basically move further. Once it will basically pass this information through this hashing function, what it will do, it will get some hash value. Let's say it has get some hash value. It will get, let's suppose this is the hash value we have received. Now on the basis of this hash value, what it will do, it will basically do the lookup into the session table. And guys, in your Palo Alto Firewall, this session table, what it has a session details, right? And this particular session details, it will store into the database called MongoDB database. So it is using this MongoDB database for storing this particular session information. And what it will do, this particular database have the sessions details in hashed form. And it is having just these hashed forms only. It will store like that, all the sessions details. And you can think like this hashed details is known as a flow key. This is known as a flow key. So now on the basis of this hashed value, on the basis of this flow key, what it will do, it will try to do the lookup into the session table. And if he found the session details, then it will move towards the fast path, which is layer 2 to layer 4 processing. If no, then it will move the packet towards the slow path, which is a firewall session setup state. Now, there's a lot more to discuss on that. So guys, this is clear from the ingress, stage, we have a flow key. We have a source IP, we have a destination IP, source port, destination port, and your layer 3 protocol number and your ingress zone details. And these are the 6 tuple information, right? And let me just show you this details so you will get the idea. Show session all. Yes, I do have one IPsec session. Oh my God. I think I am having this VPN with the AWS, maybe. Show session ID 1 or 2. So Palo Alto Firewall, when it will create a session, it will basically create a session. So it has a session ID. This is the identifier. And it has a two flow, client to server flow and server to client flow. And client to server flow, we have a source is 192.161.250 and destination IP is 52.6.50.12. This is the destination IP. Then layer 3 protocol number 50. State is active. So source port is 0 and destination port is 0. Why it is 0? Because I'll tell you the reason. I'll tell you that reason because it's a IPsec traffic. So better to show you the packet for different communication. So I'll go on my Windows machine here. Let me initiate the traffic. Yes, now I may have multiple sessions. And also let me start this server because we are taking this server as in our examples, right? So I will just initiate the traffic towards this server. (10.2.2.101) on SHS. I'm not sure I have a proper routing and other things. Yes, I do have. Web traffic. I'm not having any rule for DMZ, right? So guys, do not worry about it. Okay. Let me just delete all this. These are because this is the one of the VPN lab I have done. So that's why you can able to see. Let me just add one single rule just for DMZ access. Don't worry, you will understand everything when we will do all these practicals. Okay. So let me allow the bidirectional traffic inside to DMZ. DMZ and inside. Let me just allow. Yes, IP and everything is good. Okay. So meanwhile, it is coming. Let me just explain you. So guys, what used to happen generally? We have this PC 10.1.1.85, let's suppose. We have a firewall, which is Palo Alto, and we have a server 10.2.2.101 or running on TCP 22, Ethernet 1 by 2 and Ethernet 1 by 3. This is inside and this is DMZ. So what happens when this particular PC, it will send the very first packet. This TCP first packet is a TCP send packet, right? So when firewall do the packet processing, what it will do? It will basically, now let me write down the session details, okay? So let's suppose session ID is 100. I'm just taking hypothetically, and this session ID 100, it has a two flows, right? Client to server flow. This is the client, guys, right? And this is the server, because the initiator of the connection becomes the client and responder for that request become the server, right? So in client to server, we have the source IP address. We have a destination IP address. And we can get all this information from the TCP send packet, right? The very first packet, because it has it has IPv4 header which have that details, and it also have a layer 3 protocol number which is 6 in case of TCP. We have a source port, random port 3050. Let's take an example, but destination port is fixed 22, and we have a source zone. Source zone is inside, right? Now, for server to client flow, what details it needs? It needs the source IP address. Server to client means when traffic is coming from here towards the client, source IP become 10.2.2.101. Destination IP address is 10.1.1.85. Layer 3 protocol will be same 6. So 1 minute, let me. Your source port is 22. Destination port is 3050, and your source zone is outside, because this is the, sorry, outside, not outside, it's DMZ. Source zone is DMZ, right? Now how it will get this client to server detail? Because according to our discussion, once your routing is done, NAT is done, your security policy is done, it will basically create and install the session into the session table. And when it will install the session into the session table, it needs to install the session with client to server and server to client flow. Both flows should be there. If you go here this time, let me just restart this connection, and I must get the access this time. What the hell is this? Yes, I have. Username is VMware and password is VMware. See, I have the access of that server. Show session all. We have one SHS connection, right? Session ID is 32. Now let's try to understand this session. We have a client to server flow. Source is 10.10.1.1.100 because this is the IP address of my test machine. Destination IP is 10.2.2.101. Layer 3 protocol number 6. Source port randomly he has picked 1492. Destination port is 22, and source zone detail is inside, right? It has this details. These are the 6 tuple which he needs to create the client to server flow. Okay. And you know, for server to client flow, what it used to do, generally it flip. Whatever destination we are having here, that destination become the source. Whatever the source IP you are having, it become the destination. Layer 3 protocol number is same. Your destination port will become the source port, and your source port from this client to server flow will become the destination port. only the change with regards to the zone. We have here inside and here we have a DMZ. Now to create this server to client flow, how we will basically get that detail? So my firewall know to create this server to client flow, I need another 6 tuples, right? Without having these 6 tuples, I cannot able to create server to client flow key or server to client flow. So what? Source details, destination, source IP, destination IP, source port, destination port, and layer 3 protocol number it will get from here. And guys, because you know firewall is going to install the session in this session setup is to silo path. When it will do the forwarding lookup, so it will do the routing lookup and it will perform this routing lookup to get the egress interface or the zone details. Means it will have the zone detail as well from which firewall going to send that particular packet. And when reply come, it will expect that reply on the same interface. So that's how guys it will create that particular flow. So that's how they will basically create this particular flow, server to client flow, because it will just get this source IP. What he has to do, he has to just do the replacement, guys. He needs to just do the replacement. How it will do the replacement? This source IP address, it will replace with the destination IP. Destination IP, it will replace with the source IP. Your layer 3 protocol number is similar. Your source port become the destination port and your destination port become the source port. And this source zone details it will get from the routing table lookup. Now we have a server to client flow. So guys, what will happen when it has a this server to client flow? It will again run the MD5 hash and it will get the flow key. This is flow key number 2. And this particular MD5 from here, it will get the flow key number 1. So guys, in your Palo Alto Firewall, every session, it has a 2 flows, client to server and server to client, and it has a 2 flow keys, flow key 1 and flow key 2, and these are the hashed value. And now this is the flow key information it will store into the session table, and it will associate like this flow key belongs to session 100 and this flow key belongs to also session 100, and this flow key is for client to server flow and this particular flow key is for server to client flow. And that's how whenever it will receive a reply or either request, it will do the lookup into the session table and will basically get the session detail. If it has a session details, then what? It will basically do the fast path. It will process the packet at the fast path. So guys, this is how your Palo Alto Firewall create the sessions. Just remember, that's how your session is created inside the PAN-OS. Now, it will perform the firewall flow lookup. Firewall flow lookup match by using the 6 tuple extracted in the ingress stage. If there is no flow, because it's a very first packet, guys, it's a TCP SYN packet, so we are not having any flow, right? So it will go for the slow path. If there is a flow is available, means let's take an example. There is a one session is already available and it is just checking that particular doing the flow lookup for some type of existing connection. It's not a TCP SYN. Let's take an example. So what it will do now, it will check what is the state of a session in the session table, because each and every Session will also go through with the session life cycle, and I'll cover that one as well. Okay. So, if your session is in closing or closed state, then also your packet go for the slow path. If your session is in free state, then it will go for the discard. If your session is in opening, active, or discard state, then each and every session will also have a TTL value, right? So your TTL value is also timed out. Reset the TTL to timeout values, right? And move further. If your session is in discard state, then your session will be go in a discard state right away. If you're opening an active, then it will go here, it will reset the like TTL value or timeout value, and it will move further for layer 2 to layer 4 processing, which is known as fast path. So this is your flow lookup stage, guys. And how it used to perform all of them, if we will go here, it utilize these 6 tuple information, guys, as I have mentioned. Source IP, source port, guys, combination of source IP and source port is known as source socket. Just remember. And destination IP and destination port combination is known as destination socket. So what? Source IP, source port, destination port, layer 3 protocol number, and source zone details. It will basically create this 6 tuple. It will generate the flow key, which is a hash of 6 tuples. So we have a client to server flow key and server to client flow key, and it will basically store that flow key into the session table. And generally your session has couple of stages. Your session will go through with the init, which is a initialization state, opening, which is a transient state. You never see this stage. Active, discard, closing, closed, and free. Initial state means, let's take an example. We have received the TCP SYN. We did the flow lookup, but there is no session, and now we have sent this particular session for the session setup state. But during that flow lookup, we have already created the flow key, right? And we have associated one session ID with that. So that time your session will be in initialization state. Means we are just at the initial state right now. And you will see the initial state, which is a stable state. Means that state is available in the session table. Transient is not available, which is in opening. Active, is it available if your session is installed properly? Discard, which is also stable. You will see if your session is blocked by the firewall, then discard. Closing, which is a transient. Close, which is also transient. And free is also a transient state. So this is a session life cycle, guys. It's a session life cycle. And if you will see here, if you will check this particular session ID right now, state of your session is an active state. Session state is active right now. Okay, so that's how you will have a, if I will run this command, show session ID, show session all, we have all session is in active state right now. I'm not sure why this ppn tunnel is in active state. Okay, one minute, guys. 192.168.1.252 host. Clear session all. It is maybe trying to communicate, that's why. And if you will run this clear session, or it will remove all the sessions from the session table. Okay, now, so now guys, let's try to understand the session setup state, which is the most important state. So as I have mentioned, we have a life of a session where we have a free. Free means, see, all the session IDs, they are generally available in the free pool. You know, all session IDs initially available in the free pool, right? When we receive any packet, your firewall take out one of the session ID from that particular free pool. And if your communication has been done and your session is discarded that time, this particular ID he needs to return back to that particular free pool. So that is known as free. Now guys, there's no session. So now your packet reached into the slow path, which is a firewall session setup state. In session setup state, what it will do? It will do the forwarding lookup. It will do the lookup into your policy based forwarding rules. If there is no PBF rules, then it will fall back to the routing lookup. If we have a policy based forwarding, then firewall take the decision according to the PBF rules. It will bypass the routing lookup. Just remember. If there is no PBF rules, then ultimately it will do the lookup into the routing table. And the main purpose of doing this lookup into this particular forwarding lookup to get the egress interface and the zone details. Because when we receive any packet, firewall will not keep this packet. It will not store. It will process and it will egress out. It will exit out that particular packet through the interface, right? So it will do the lookup to get the egress interface. In case of layer 2, it will do the lookup into the forwarding database, FDB lookup. So from here we will get the egress interface and egress interface and the egress zone. Now it will move further for the next check, which is net policy lookup. Now your firewall start doing the net policy lookup, and guys, your security policy evaluation happens from top to bottom. Okay. So, now your firewall do the lookup, and if when we are doing the lookup into the net policy, let's suppose we have found a rule and that rule is changing our destination. Means because of that rule, destination IP address will change. In that case, if your destination will change, then there is a high chance your egress interface will also change. So in case of destination net, it will do the routing lookup one more time. If your packet is matching the source net, then it will move further. So if you will see here, if destination net is present on the match rule, do not second forwarding. Do the second forwarding lookup to get the final egress interface. Means it will do the lookup again into the forwarding table or routing table or the PVF table or PVF lookup. And guys, here firewall just do the net policy lookup. It will not do the change. It will not do the net translation. Net translation is not performed here. Just remember, because net translation performed here into your fast path. Here we will just get net rule number 2 is matching for us. This is the thing, whatever, this is the thing he will get from this net policy lookup. Here it will just do the lookup. This is the net rule which is matching. And after that, it move further for the firewall security policy lookup. Now here your security policy evaluation happens. And here when it will do the lookup into the security policy, it will consider application as any and URL as any. Use application as any to see if there is any rule match that allow packet for given address and ports. By default, allow same zone and deny different zone traffic. So it will basically, it has a two default rules, intra-zone default rules, which will allow the traffic within the zone, within the zone communication is allowed by that rule. And if communication is happening between the zones, means inter-zone communication, like inside to outside or inside to DMZ, that type of traffic firewall blocked generally. If we have a security policy rule and there is a one rule is matching, if rule is matching and the action into this rule is allowed, then what it will do, it will create the session and it will install this session into the session table. If your rule is denying the packet, what it will do, it will discard your packet right away. And guys, if your packet is discarded by the security policy, then you will get the log of that into your monitor tab. If your packet dropped at routing, at net, you will not able to see any type of logs. So it's not always true. If something is not working and you are not able to see any traffic logs on your firewall, it's not like that your firewall is not blocking, not, or your firewall is not discarding this traffic. Maybe firewall is discarding because there is a hell lot of checks are happening. So guys, this is your silo path according to the Palo Alto Firewall old diagram of 2010. Now let's try to understand with regards to the new diagram. So now, according to your new diagram, we have received a packet into your silo path, right? And when we receive a packet into this silo path, what will happen? Now the very first task it will perform, which is known as zone protection. We can able to enable the zone protection at the zone level. Let me just show you here. If I'll go into my firewall, network, we have this zone protection. If I will create one of the zone protection, you can see this zone protection profile will protect us from the SYN flood attack, ICMP flood attack, other IP flood attack, ICMP version 6 attack, and UDP flood attack. These are the, it will protect us from these type of flooding attack. You can select these options. And guys, these are the default values, and each and every platforms has these default values. For SYN flood attack, either we can use random early drop, either we can use SYN cookies method. And we will discuss these SYN cookies method or random early drop in your live sessions, like in your actual class where I will cover the zone protection. Here I am just telling you. Okay. Then it will protect you from the TCP port scan, host sweep attack, and UDP port scan. It will protect you from the packet-based attack protection, like if you are receiving spoofed IP packets, strict IP address check, fragmented traffic, IP option like a strict source routing, loose routing, time step, record route, right? Security stream, all these things. TCP packets you can drop for split handshake, mismatched overlapping TCP segments, right? And it will also drop a packet which like TCP SYN with data, TCP SYN ACK plus data. It will also reject non-SYN packet, means in case of TCP, always we have a first packet as a SYN packet. If we are receiving non-SYN packet as a first packet, then it will drop that packet globally. And your asymmetric path packet will also drop, means let's take an example. We have a firewall, we have a PC, and we have a two internet path, Ethernet 1 by 1, Ethernet 1 by 2, and Ethernet 1 by 3. And we have one server here. Let's take an example. Your traffic is going in this direction, and when reply is coming, reply we are receiving on this one. This type of traffic is also dropped by the firewall because of this asymmetric path. It will track all the asymmetric paths. TCP packet with the timestamp option, TCP fast open. So fast open is a algorithm in your TCP. So if you are receiving these type of packets, it will drop these type of packets. For ICMP drops, ICMP packet with ping ID 0, ICMP fragment, ICMP packet, large size packets, right? So it will drop these packets. Then protocol protection, you can write down the protocol protection and all. For ether type, Ethernet SGT protection, even though I have not used these particular two features, but they are there. Okay. So if you have such type of protection, these things comes under the zone protection, guys. Even though you can also able to create the DOS protection policies. So it will protect you from the DDoS type of attacks, right? You can able to create the rules. You can able to define protection, what you want, right? What are the services? So you can able to define all that particular details here for the DOS protection as well. And we will discuss these particular things practically in your classes. Okay. Now, let me come back here. So as I was mentioning, it will check for the zone protection profile. And if there is any type of anomaly on your packets, or if there is any type of error, and if your randomly drop is triggered, what will happen? Your packet will be dropped here. And that particular packet, it will also add into the DOS block table. This type of packet, it will also add into the DOS block table if some type of attack is happening. And it will also perform the TCP state check. It will check the TCP state. Is it's a first packet? So our SYN flag is set 1 or not? Is the first packet having the invalid combination, like SYN flag is SYN flag set 1 and FIN is also set 1? Means it will check the state of the TCP connection. And it will discard that type of packets here as well. And you know, as I was mentioning, it will create the DOS block table, right? So guys, read through these articles. And this is the command debug data plane show DOS block table. If you will issue this command debug data plane show DOS block table, if there is any IP address into your DOS block table, you can able to see by running this particular command. Okay. You can remove this particular packet by using this particular debug data plane reset DOS zone outside block table source and all, right? Debug data plane reset DOS block table. You can do this thing. Tunnel decapsulation. Why I think, oh, this is a part of DOS block table, right? So it will maintain this DOS block table. Now, as I mentioned, source protection profile check, randomly SYN cookies, right? TCP state check. If the TCP stateful inspection is enabled, non-SYN packets for new session will be discarded and all, right? If ACK packet received from client does not match cookies encoding, it treats packet as a non-SYN and discard the packet, right? So it will do all such type of checks basically. You can also change these settings globally by using this particular command. You can also turn the TCP state check back on by using this particular command. You can disable these settings temporarily, right, by using this CLI. You can disable or you can disable or enable the asymmetric path check bypass. You can bypass the asymmetric routing, right, by using these commands. Read through it. Okay. And you can also issue this command show running TCP state match asymmetric, and you will get the idea. If you will run this command show running TCP state, hit enter. If anything, what's going on there, what's configured, you will get everything here by running this particular command. Okay. Now, and after that, guys, they have done one more very good optimization into the silo path itself. They have basically introduced the user IP or user group cache information, because each and every firewall maintain the user to IP mapping or users to group mapping when we will enable the user ID features in your Palo Alto firewall. If we have that feature configured, then your firewall basically create this user IP mapping or users to group mapping, and it will basically enforce this particular mapping if your ingress zone has the user ID enabled, because we have to enable the user ID at the zone level. At each zone we have to enable this user identification. Like here we have to enable the user ID. Let me just check if I have a user ID set up. I don't think so, because yeah, I do have, but connection is right now it's not connected because my AD server is not up and running. Okay, so you will also get the user to IP mapping basically. Let me just do, if I'll go here, okay, I think portal and Google Gateway is not there, otherwise I can show you this user ID things as well. Okay, not an issue. So now you know it will basically check this user IP or user to group mapping, right? And you know you can issue this command. So user IP user mapping. So it will maintain these mapping at the data plane and at the management plane as well. You can issue all. You will get, so like there is a, it is not, it is trying to create one mapping, but you know right now because the AD is not connected, so we user is unknown, and how it will get the mapping which is also unknown. But you know it will try to create that mapping like that because user ID is configured. Okay. IP user or user group check if ingress zone has user ID enabled. And after that, what now it will perform the application check. Here it will also introduce one more feature called app ID cache. Because you know, whenever my firewall receive a packet, whenever it will basically do the app identification, what it will do, if we have identified the application as Facebook, so what it will do, it will store the information of destination IP, destination port, and protocol number. These three values it will store into this app ID cache, which is a part of Silopath. So let's take an example. User 1 has initiated the request for Facebook at 10:30. So now for there is a mapping is already created for Facebook on the basis of destination IP, destination port, and protocol. Now there is a one more user 2. He has also accessed the Facebook at 10:32. After getting the app ID mapping or app ID cache details for Facebook. So what it will do for user 2, your packet don't need to go into the app engine. Your app details we will get from this particular cache as well in the silo path itself. So that is the benefit it will basically get into your Palo Alto Firewall. So guys, this is also one more very good, or it's a optimization feature of your firewall. And now once basically these things, user ID and app ID cache, it will check. And if you want to read more about that details for user ID, we will discuss all these things in user ID, but you can check this out. For application check, identify the application if matched with destination IP, destination port, and protocol. Command to clear the app ID cache, you can run these commands. You will get debug data plane, reset app ID. So running application cache, you can able to get if there is any type of cache is available. So right now you can see there is no cache, right? But if I'll just do one small, if I'll go here into this machine, if I'll just reset this or duplicate this connection, let me also try to open facebook.com, VMware. Now if you go here, if you run this command, now you can see App ID is not updated. So session all. We have a session with SHS protocol. Then yeah, see there is a details. We have a destination IP, destination port, and protocol number. That details it will store right away. Okay. So that's how it will basically maintain the app ID cache. Now it will do the lookup for forwarding again. Routing lookup, right? It will do the routing lookup just to get the egress interface, right? So it will start do the lookup for layer 3. It will check on the policy based forwarding. If we have a PVF, then it will basically get the egress details with the policy based forwarding rules. Otherwise it will do the lookup into the FIP table. So guys, generally in firewalls we have a FIP tables and we have a route tables. So it will do the lookup into the FIP table. Okay, it will do the lookup into the FIP table. For layer 2 it will do the lookup into FDB lookup. Then it will perform the net policy evaluation. In case of destination net, if yes, then it will go for the route lookup again. If no, then it will basically now enforce the authentication policies. It will enforce the authentication policy lookup and trigger the captive portal if match. From here, we can basically enforce the users whenever he is trying to access any website. First, he has to basically authenticate himself on the basis of captive portal. So when we will discuss user ID, that time you will understood that part. And after that, it will basically go for the DOS protection policies. DOS policy lookup on the basis of pre-net IP and post-net zone. If your packet is matched any DOS protection policy according to the action we have defined, your file will take the action. Otherwise, it will move further. So it will match what type of DOS policy we have configured, aggregate or classified threshold. If yes, then it will drop the packet according to the random early drop or it will discard. If no, then it will do the lookup into your security policy. So it will uses the pre-net IP, pre-net IP address, ports, post-net zone details, application any, URL category any, and then matches the rule. If it will skip any rules with action not set to allow if the application and URL category matches. If no config used rules match, then default rules if there is no rule is matching, then it will basically match the default rules, intrazone default or intrazone defaults. So it will do the security policy evaluation from top to bottom. Top to bottom. It will consider your application as any and your URL category is any. If rule is matching with allow, yes, then it will create the session. If no, then it will discard the session. It will create the session for client to server flow and server to client flow, source IP, source port, destination IP, destination port, source zone detail, and layer 3 protocol number. Same for server to client. Now, once your session is installed into the session table, guys, there is a new feature which is added into your Palo Alto, which is tunnel inspection policies like TCI policies. Have you heard about the 7-layer protection or 4-layer protection like your cryptocurrency communication? They have a 7-layer of protection and all, right? It's the same thing. They have a 7-layer of protection doing this TCI tunnel related policies. They have created a in tunnel, then tunnel, then tunnel, then tunnel. So it will basically a firewall can also able to inspect the tunnel traffic for TCI based policies, but firewall only can able to do the tunnel decapsulation at 4 layers. Just remember. protocol, GRE, GTPU, IPsec, non-encrypted VXLAN traffic? If yes, then max tunnel reached. If yes, then it will for further. If no, then perform the tunnel inspection. Okay. And once tunnel inspection is done, it will basically go back again to your session setup state. Otherwise, if everything is good, there's no TCI policies, then your packet go for the flow session. Here your session will be installed, your session state will change from as active, and your timer is also set. And guys, who manage these timers? And also in your Palo Alto Firewall, we have a ager process. That ager process will maintain these timeouts, and after that your layer 2 to layer 4 processing will start, which is your fast path. So guys, this is all about the slow path inspection. Guys, I got one question on the chat. So let me tell you, see, whenever your firewall receive a packet, either into this interface, either into this interface, either pack, see, they are doing that communication like this, right? So now your each and every packet is inspected. Each and every packet will go through with the ingress stage. In ingress stage, what is the main purpose? The main purpose of ingress stage to complete the parsing of your layer 2 header, layer 3 header, layer 4 header, check your DOS block table and get the 6 tuple information. Once we have a 6 tuple information, we will generate the hash and we will basically match the hash with the session table. So your each and every request and reply packet will be matched against the session table, and that's how only we will know there is a one existing session is available for that communication. That's how we will get to know there is a existing session available for this communication on the firewall. Okay, now let's try to understand your layer 2 to layer 4 processing. So guys, see, with regards to packet flow, if you can able to recall this very big one, that is also okay. If you are not able to recall that big one, then just recall that one, that is sufficient. If you know this one, that is also totally sufficient, it's enough with regards to the interview purpose. Just give me 1 second. Okay, now, so now guys, what used to happen then? Now your packet is at fast path, your packet is reached here into this stage. Now what it will do, in your fast path, your packet may be discarded if session is not in active state. It will update the session lifetime or do net if applicable. So what it will happen, sometime your session will be in discarded state, as I have mentioned, right? So these type packet it will be discarded. But you know, when your packet reach into the fast path, what it will perform two lookups again. For the, it will apply the net. So it's not a lookup, it will just do the net translation. Means if let's suppose you have configured the destination net or maybe the source net, maybe that IP is 10.1.1.100 may be translated on 192.168.1.250. If you have configured, let's suppose, port address translation, which is dynamic IP and port, right? So your actual net translation happens here into the fast path. Now you may ask one question, why we are not doing the net translation here? Why we are just doing the only evaluation here? Guys, there must be some reasons, right? So tell me one thing, is your each and every packet will go through with this state? What are the packet will go through with this slow path of session setup state? What are the packets, guys, or which packet generally go through with the session setup state? Only the first packet, or either the first packet or the new packet? only the first packet from the flow will go through with this slow path, right? And after that, each and every packet will go through with the fast path. And guys, we have to perform the net translation for each packets, right? So guys, that is the main reason your net is applied here. Now you can ask one more thing. There's a one more task done at the fast path. So I will just introduce in some time. So once your net translation is happening, now your packet go here, and here it will basically go for the SSL decryption or SSL proxy. Now, if we have configured the SSL decryption in your Palo Alto firewall, then what will happen now? Now in your Palo Alto firewall, what will happen? Now your SSL engine kicks in a picture. It will kicks in, and what it will do? From the packet, it will extract the layer 7 information, and it will store that layer 7 information as a FPTCP segments. What is these segments? FPTCP segments are the forward proxy TCP segments. It will store that data into as a FPTCP segments. And now, because you know this layer 7 data, we have to store somewhere. And after that, only this SSL decryption will trigger, because we have a dedicated SSL engine inside your Palo Alto firewall, or dedicated hardware chip inside your Palo Alto firewall who will perform this SSL decryption task. Okay, now your SSL decryption kicks in. It will decrypt the packet. Now, if your session if your application is already available, means we know the session app identified. If yes, then it will move packet towards the content engine. If no, means let's say it's a first packet, it's not a TCP SYN packet. Generally TCP SYN, SYN plus ACK and ACK, they will not go through with the app engine and content engine, because they are not having any type of layer 7 data. Just remember. Okay, so now let's suppose your app is not identified, then what will happen? Now your packet go into the app identification inside the app engine for application identification. If your application identification is happened and we know the application, then this packet will go through with the content engine. And now guys, you can tell me one more thing. How my firewall will know, or from which packet onwards it needs to basically start the SSL decryption? Guys, first my firewall needs to identify if traffic is SSL or not. So your first packet will not go through with the SSL, will not go through with the forward proxy. Once your application is identified as SSL via the app engine, you can see if application is identified as SSL. If yes, then go for the SSL decryption. See, then your SSL proxy will kick in. And when your proxy used to kick in, what will happen? There is a one star tag is added with the session, means now my firewall know this particular session or this particular traffic needs to go through with the SSL decryption. Okay, now let's go here. Let's see your fast path processing. So yeah, you know, in your fast path, it will start layer 2 to layer 4 processing again. It will apply the net if applicable, run the net, and it will run the IP translation and the port translation. If there is any error at this stage, what it will discard the packet right away. Now it will also perform the forwarding lookup again for all client to server and server to client packets. Now you can ask why we need to perform the forwarding lookup again here. What is the reason? There must be some reason, right? Now, you know, this particular forwarding lookup required because when we will get the reply for server to client flow, when we will get the reply from the server, how my firewall know he has to forward this packet to which, through which interface? So that's why it will do the lookup again. And let's suppose there is some changes happens on your fib table. In that case also it will do the routing lookup again or the forwarding lookup again. And if there is no route, then your packet will be discarded. Or if your zone is changed, then also your packet will be discarded. And after that, now your SSL proxy, it will check, is your session having the SSL proxy sessions, or your session is flagged for the proxy? If yes, then your SSL decryption will happen. So it will apply the decryption if applicable. Means we have to configure the decryption rules on the firewall, and we will decrypt all the packet for the SSL based applications. We never decrypt we are not allowed to decrypt here tunnel traffic and all. Tunneled is something different. Here we are talking about the SSL related traffic. Okay, we are not talking about the GRE IPsec. No, that's the different story. Here I'm talking about the HTTPS based traffic or the SSL based traffic, because SSL decryption is only applicable for the SSL traffic, not for the tunneling and all. Okay, now if SSL decryption is applicable, then it will check, is application identified in the session? In our case, no. Now your packet go inside the app ID engine. Now let's try to understand the fields in app ID engine. So guys, when your packet go into the app engine, the very first task happens what? We will check application override policies. Is our traffic matching with the app override rules? And we will configure these app override rules to bypass the app ID. To bypass the app ID, app identification, we will configure this app override rules. And we will always configure this app override rules for the internal traffic. Let's take an example. We know this traffic is our internal traffic. We don't worry about it. Why we will enforce the app identification? Just to enhance the performance of the device. So it will check for the app override lookup match. If yes, then it will check security policy with application. If no, then it will what it will do? It will basically check the pattern based application identification. Now from here your app identification kicks in, and your app identification is start from here. So it will check it will try to get the application on the basis of application signatures, on the basis of known protocol decoders, unknown protocol decoders. It will basically do the behavioral analysis or the heuristic checks just to get the application. Once we get the application, we will enforce our security policies again, because on your Palo Alto Firewall, we used to configure the rules on the basis of app ID, right? So now it will check the security policies again for that application. We are allowing that traffic or we are denying this traffic. If there is a rule match happens and on that rule we are denying this traffic, means allow no, then it will discard that packet. If yes, then it will basically check on that particular rule security profile configured or not. Security profile are the layer 7 security profiles, like for antivirus, for anti spyware, for vulnerabilities, right? For URL filtering. If into that particular rule we have a security profile are configured, then what will happen? If yes, then what we will do? We will add that particular flag also on my session. Now I will add the flag and I will basically now check if there is any type of quality or QS policies lookup. If we need to set class with the QS marking on this session, right? I will check the QS policies if needed. Then move further. Application identified as SSL or SHS. So you know your SSL decryption guys applicable for SSL traffic and SHS traffic, because people used to create the SHS tunnels nowadays. Decryption policy lookup. See if your application identified as SSL or SHS. If no, then it will move towards your content engine. If yes, then we will check decryption policy lookup match happens. If your decryption rule is not matching, then it will move towards the content engine. If yes, now it will matches the decryption exclusion cache. So there is a one exclusion list, like we cannot able to decrypt the traffic for WhatsApp. We are not able to decrypt the traffic for some of the some of the I can say some of the websites traffic we are not able to decrypt because of their certificate. Maybe they are using the certificate pinning, or maybe they are using the illegal combination of encryption and authentication algorithms and all, right? So we will discuss these lists as well in your SSL decryption, right? So if your traffic belongs to the matches the decryption exclusion cache, if yes, then it will go into the content engine. If no, then it will basically go for the SSL proxy and your flag is added. And now once your flag is added, now you can see your packet is go back again into the fast path for SSL decryption. And when your packet reach into the SSL decryption, now what will happen? Your SSL decryption will start. Okay. And how SSL decryption happens, what type of certificate we have to create, everything I will discuss in your SSL class, because we have a 3 hours of session on that. So that time I will cover. Here you just know SSL decryption we will configure just to encrypt, just to decrypt the SSL based and SHS based traffic, so firewall can read the actual layer 7 content against the malwares and viruses. Okay. Now once app ID is complete, now your packet basically go into the content engine, which is your CTD engine, content threat detection. Flags or layer 7 enabled in the session. If yes, now your content inspection start from here, and your actual single pass software is also applied at the CTD engine only. Now content and threat detection with pattern matching, and your content engine will also detect if there is any type of application shift is happening. If yes, if there is application shift, then your packet again go inside the app engine. If no, then your packet is parse against the decoders and all, right? It will match against the signature database for antivirus, spywares, vulnerabilities and all, right? And if there is any type of threat detected, if no, then your packet go here. If threat is detected, yes, then we will check apply security profile action. What is the action we have defined? Drop, reset client, reset server, reset both. We will basically, if these are the action, then we will discard the packet. And on the session level, what we will change the session state from active to discard. At the session level also we will change the state from active to discard. If we have had the action as alert or allow, then we will basically again your packet hits for the SSL proxy. So whatever data we have decrypted in the fast path, now we will again re-encrypt that packet. If applicable, forward decrypted traffic to the security chain. If there is a, so guys, there is a one more thing. If we have a, there is a one more feature in Palo Alto Firewall. We can use Palo Alto Firewall as a SSL decryption broker. Means it can firewall decrypt the packet. It will send that particular decrypted packets towards the other devices. So we will discuss these particular SSL broker. What is this in your SSL class? Okay. So now whatever packet we have decrypted, now we will again re-encrypt that packet, and we will move further and we will forward that packet towards the forwarding stage or egress stage. In forwarding, what your packet forwarding processing start. Use the ingress interface to get the forwarding domain. Do route switch or vwire of vwire type of forwarding, right? Packet ingress process If fragmentation needed, then it will do the fragmentation and all. If quality of shaping or QoS shaping is needed, then it will apply the QoS shaping. Now it will check what is the egress. If your traffic is egress towards the tunnel interface. If yes, tunnel interface means it's the traffic of either IPsec VPN or either SSL VPN or either GRE. In case of IPsec, what we will perform the encryption, then we will create the hash, and after that we will encapsulate that packet inside the ESP packet. In case SSL VPN, we will encrypt, create the hash, and that particular encapsulation happen via the TLS header. For GRE, hash is added, encapsulated, and after that we will basically forward this packet through the outside interface. So guys, that's the packet flow of your Palo Alto firewall. If you will see in forwarding stage or egress stage, right? If tunnel traffic for SSL or IPsec VPN, right? It will needs to basically encrypt the packet, needs to create the hash, then it needs to encapsulate the entire packet inside the ESP header or the TLS header, and after that will transmit this packet. And guys, your URL filtering, everything is happens here in the content engine. All your 7 tasks like antivirus, anti-spyware, vulnerability, file blocking, URL filtering, wildfire, data protection, all these tasks done by the content engine. And when we will discuss individually these engines, you will get the more idea on it. Okay. Now I will share this document, guys. Read through it properly. You will get the whole idea of it. Okay. Now, so guys, this is all about the Palo Alto firewall packet flow. Now, one more thing I want to tell you guys. See, I will just use this particular diagram. So, see, if your packet is dropped by the firewall at ingress stage, you will not get any type of log. Log will be not there. If your packet is dropped due to routing, due to NAT policy, there is no log. If your packet dropped by the zone protection, there is no log. In case of zone protection, it do create the it basically do create the DOS block table. If your packet dropped by the security policies, you will get the traffic logs. If your packet is dropped by the security policy as application level, you're basically you will get the log. If your packet is dropped by the content engine, then you will get the log. But if there is any type of issues with the SSL, you will not able to see these logs. How we such type of troubleshooting we used to do? We used to basically do these troubleshooting with the help of counters. These are the counters we will always check. And guys, when I will explain you the packet based troubleshooting, if your let's suppose your packet is not reaching, right? The very first thing what I will start my troubleshooting by checking these counters. If I will not able to resolve that issue with the hello counters, then I will basically move towards the filters. Captures, then flow basic. That's how I will start my communication. Like, and when you will do the flow basic, you will able to take out these type of stream. How Palo Alto 5 process the TCP SYN plus ACK, then acknowledgement packet, then HTTP get packet, how he is processed. So even though I will help you how you can take, how can you will get this particular entire packet process and how you can take out these type of TCP streams. I will cover that part as well in your sessions. So, but to reach that particular stage, we have to know everything on your Palo Alto firewall. Okay. Now, I hope you got this, your answer sec, right? In the monitor tab, we will only able to see the traffic logs, threat logs, means your traffic is dropped by the security policies. If there is anything else like URL filtering, you will able to see the URL filtering means because it's also a part of security policies only. But if there is any other issues like your hardware, there is a hardware issues. There is a problem at the routing. We are only having the ways to check these issues with the help of routing only, with the help of these counters only. Okay. Now guys, this is, I think it's, we have discussed enough information with regards to packet, with regards to packet flow. Let me just see if I do have anything else here. This information you already know because we have covered in your yesterday's session. Yes, Saru, like your SSL packet will only decrypt it if there is a flag is set, and your flag is set if you will configure the decryption policies. Okay. Now let me guys just start your SP3. SP3 is also most important topic of your Palo Alto firewall. Put your full attention with regards to this SP3 discussion now, because we have around 1 hour of time. Okay, guys. So what used to happen generally in your Palo Alto firewall, if you will see this particular diagram, that's the official Palo Alto document. In this document, if you will see here, Palo Alto firewall generally divided its architecture into two parts. It has a architecture at the software level, and we have to understand the architecture at the hardware level. So the full form of SP3, this term SP3, SP3 stand for single pass software and parallel processing hardware. Single pass software and parallel processing hardware. So SP3 is a combination of two terms, single pass software and parallel processing hardware. So guys, this single pass software we will discuss in some time. Let me first explain you the parallel processing hardware. So guys, in your Palo Alto firewall, hardware is divided into two planes. We have a control plane, which is known as management plane, and we have a data plane. Means Palo Alto firewall segregated the management plane, and he has segregation at the data plane. Means both of these planes, they have a individual task to do. This management plane has his own resources. Resources means it has his own RAM, CPU, SSD, or storage, right? These are the main resources. It has their own resources, and your data plane has their own resources, RAM, CPU, SSD. Means there is no dependency on each other at the resource level. Means if your management plane is functioning, it will function well and it will utilize these resources, and your data plane utilize their resources. Means if some type of DDoS attack is happening on your management plane, our data plane is safe. It will not impact your data plane. If there is any type of issues is happening at the data plane, then your management plane will not impact. You will get the so we don't needs to basically worry about on it. If DDoS attack is happening in data plane, your data plane will impact, but your management plane is safe. Okay. Now, this is the one benefit you will get with regards to the parallel processing hardware. Means it has a dedicated management plane and dedicated data plane. Now, what Palo Alto have done, Palo Alto have divided its data plane into three another planes. Network processor, security processor, so I'm just putting a Octeon chip, and this signature match processor or the pattern match processor, we have a Jaguar chip. That's why I have discussed the data path with you guys. Now your data plane is further divided into three another planes, and guys, these are the dedicated hardware chip or ASIC. They have a dedicated RAM, dedicated CPU. Each and every chip, they have a dedicated RAM and dedicated CPU, and they have a dedicated task to do. Means your data plane chip is also not having any type of resource level dependency. Means they can perform or they can perform their task independently at the resource level. Because what used to happen in other vendor devices, they are having the shared RAM and CPU. If let's suppose this particular process has acquired around 80% of RAM and CPU, then what this processor will do or what this processor will do, it will not able to perform well, right? So that was the problem we are having into other vendor firewalls. And guys, that is the main benefit we are having in Palo Alto Firewall. And that is the main reason Palo Alto Firewall is around 3 times higher in comparison to the other vendor firewalls because of its SP3 architecture, because they have done the segregation at the data plane also. Now, you will also get one more benefit with regards to this segregation at data plane and control plane. Let's suppose there is some issue you are having at the data plane. Guys, tell me one thing. Let's suppose your laptop is hanged. What is the best solution to recover from this stage on your laptop? Or what you will perform generally? Restart, right? Or either reboot. Both are correct, right? So the thing is, in your Palo Alto file, you will get a flexibility to just reboot your data plane. Just restart the data plane only. You don't need to restart your management plane, or you don't need to restart the entire box. You can just reboot the data plane only, and you will basically recover from your problem. But now you may ask one thing. Let's take an example. In your management plane, you are trying to log in into this device via SHS, but you are not able to log in. You have a configuration is correct, everything is correct, everything is good, but you are not able to log in. So what you can do? What we will do, we can restart the SSHD daemon. We don't need to restart the entire management plane. We can restart the particular. Let's suppose your user ID is not working fine. We can start the user ID daemon. Let's say your IPsec VPN is not working. Start the IMGR daemon. Let's suppose your global protect is not working. Restart the REST manager daemon. Let's suppose your web UI is not working. Restart the web server daemon. Let's suppose your authentication is not working. Restart the auth3 daemon. Because your all the daemons are running into your management plane. Now, one more thing, guys. Can we able to restart the only management plane? If you will restart the management plane, so generally we are not able to restart the management plane only. If there is any issue at your management plane, we have to restart the entire firewall. If there is an issue at the process level, we can restart just that particular process. And you know, if there is any issue with the multiple processes, you don't need to restart. Generally, in your management plane, we have a one daemon called master D. And master D is a main daemon who is basically father of all the daemons. All the processes is initialized and initialized by the master daemon. Then we have a one more daemon called system daemon, sysd. System daemon will control all the processes. Means let's suppose if user ID wants to communicate with auth D, how it will communicate? So they will communicate by a system daemon. Sysd is a mother of all the daemons. And guys, if there is any type of issues on your firewall management plane, we have to restart the master D. So Madhu has asked, what is the purpose of management server? Management server is a different daemon. Management server is known as, so management server daemon is responsible for multiple things. It is responsible for your config management, your all commit related tasks done by the management server daemon. Okay. So if you guys just want, let me just share you one more diagram here. And do not ask such type of diagrams to share, because these are the diagrams which is from my troubleshooting class. Okay. But you, just for the knowledge purpose, let me share you how these daemons are connected, because then you will get the entire idea. Let me just open pan OS management plane. I hope this diagram is visible to everyone. So guys, this is how the daemons architecture looks like inside your pan OS. So we have a master D manager, and one core of your master daemon is running in your data plane, and one core of your master daemon is running inside the management plane. And this master daemon has a connectivity with the system daemon. So whenever your firewall is restarted, first your master daemon will initialized, and after that it will initialize the system daemon. Once these daemons are up and running, now master D daemon will instruct the sysd to basically start all these other daemons, system daemon. Even though system daemon will also control all, we have a very few daemons at the data plane, like your supervisor. This daemon will help us in the URL filtering, URL lookups and all. We have a pen DHA. This daemon will use for the in your high availability to exchange the session information through the HA2 interface of your Palo Alto Firewall or the data interface. We have a EHMON, this is for interface. Then we have a tunnel D, this is a tunnel daemon for your IPsec tunnels. SysD agent. Then we have a BRD agent, MP relay, PANCOM, and the main daemon is pan task. This is the main daemon in your data plane which is running, and it will basically process your packet. Whenever we receive any packet in your data interface, this is the daemon pan task who will basically do the start the processing on it. Then we have a system daemon. Then it has a connect with the REST manager, VRD agent, H agent. FBEP3 is a PHP layer we have, where we have a web server, SSL, BPN, L3, SBC, where receiver, crypto D, route D, EHMON, SysD agent, F manager, DSCPD, DNS proxy, auth D, IKE manager, key manager, Dagger, SN, MPD, SSL manager, log receiver, user ID, and master management server. This is the management server daemon which you were asking. Management server daemon will have a connectivity with the sysd, user ID, because user ID information is also managed by the management server, log receiver, and dev server. And all these daemons will communicate with the system daemon on TCO 28260. And your user ID, your dev server, user ID, and and log receiver, they will communicate with management server daemon on port number 10,000. Even though you can check it out, these how their communication. So if you will run one command, so netstat numeric yes match 28260, you can see there are a hell lot of connection are established. See, some are in TC beta state because your internal daemons, they are communicating with the management server. Then we have a one more thing, 10,000. There is a communication on 10,000 as well. Okay. Now, so this is how these daemons are connected, guys, just for the knowledge purpose. Let's back to our actual topic. So as I have mentioned, guys, we cannot able to restart the management plane, entire management plane. If we have to restart the entire management plane, we have to restart the entire firewall. Okay. And there is a command. So if you will run this command, request system request restart, you will get the system right now. But if you will run the same command in your hardware boxes, you will get the data plane here. If you have a firewall with multiple data planes, then you will basically get the multiple DP0, DP1, DP2 type of things for restarting this particular data plane only. Restart system software, request restart system, not this one, system software, request software debug software restart process, and you can restart the individual daemons by using this particular command. Let's take an example. I want to restart the key manager, right? So I will just type here key manager. If you know the core, yes, or you can just restart the key manager by running this command. It will restart this particular daemon. Okay. And all these daemons files are available inside this mp log. You can able to see all the files are here. Yes, you will see all the log files. Even though if I'll show you the authority log, you can able to see authentication rate. See, let me show you one thing here. Let me open my putty. One 192 168 137.22. Let me try to log in and you will get the logs. Accept admin. Let me put the wrong password. Admin 123. So 1 minute. Tail follow yes. MP log auth3. This is how you can use this command, and you can see the authentication failed. And when you will add this tail follow yes, we will get the live logs. If I will enter one more time wrong password, you can see it is changing. If I'll put the correct password like admin at 123, it succeeded, right? So guys, troubleshooting is very easy if you know the concepts, if you know how to check these log files and all, right? See, if somebody is not able to log in, check this particular daemon log file, you will get the answer what's happening. Okay, now let's back to this SP3. And guys, by end of all these classes, you will get the idea on all these topics because I will cover all of them. Okay, now, so we have a control plane and management plane. Now this management plane is further divided into three another planes: network processor, security processor and signature match processor or the pattern match processor, right? Now if you will see this particular diagram here, we have a control plane. Now this control plane has some tasks to do, or the management plane has some tasks to do. So in your management plane, first of all, we have a dedicated CPU, dedicated RAM, dedicated SSD, dedicated management port, and dedicated HA ports. And this HA port is known as HA1 port. What is HA1 port? You will get the idea in HA class. This management plane is responsible for your configuration management. Means if you want to perform any type of configuration, this is the plane who is responsible for logging and reporting. These are the three tasks majorly done by this daemon, plus this particular management plane, and all the daemons are running here. These are the tasks which is done by the management plane. And guys, whatever CPU you are having, they are the normal Intel based CPUs. Okay, they are the normal Intel based CPUs. But we have a data plane here. In data plane, we have a network processor, security processor, and signature match processor. And guys, these particular processors, like your Tiger chip, your Octeon chip, or your Jaguar chip, generally these are the dedicated chip basically which is designed by the Intel for Palo Alto devices. Okay, and you know the so your network processor is responsible for layer 2 to layer 4 processing, but for which packets? The packets or the session which is offloaded by the Octeon chip. Because this network processor can able to do the flow control, means it can able to manage the sessions, your route lookup, ARP lookup, MAC lookup, QoS, and NET. And guys, these are the tasks which we have to perform on a session, right? So all the offloaded session handled by this processor. Security processor will perform all the tasks of the network processor, means it can able to do the processing on layer 2 to layer 4, right? The security processor means your net security evaluation, your net rules, your security rules, your routing, creation of FIP table, right? Maintaining the sessions, everything done by the Octeon chip. Means this is the chip who will enforce the security policy. And guys, it is having dedicated RAM and dedicated CPU. It is not having any type dependency at the signature match processor. And guys, in your firewall hardware, we have a dedicated SSL engine, IPsec engine, and decompression engine. These are the dedicated small hardware chips inside your firewalls for doing the SSL related tasks, IPsec related tasks, and the decompression related tasks. Guys, there is a one request. During the session, just ask the question from the topic, whatever I am discussing. If you will ask the question from here and there, right, these questions just you can put into the Q&A session. I will love to answer. But during the session, ask the question from the current topic, and that's how you will basically get the whole idea. Okay, now, now guys, see, this is the Octeon chip, and this chip will process the packet. So Tiger, guys, Tiger chip is a dedicated FPGA S6. Okay, it is a FPGA field programmable gateway array. It has a inbuilt in this particular CPU and RAM. Okay, and this security processor is a multi-core CPU. Here we have a multi-core CPUs. Why? Because this particular processor do lots of tasks. Then we have a signature match processor. This signature match processor have a dedicated RAM which is responsible for app ID and content ID. And guys, one more thing to remember here. In your signature match processor, we have a two algorithm, AHO and DFA. AHO responsible for app ID related task and DFA responsible for the content ID related task. And nowadays this DFA is replaced by the p-scan algorithm. So your thread is scanning done by the signature match processor. Okay. So guys, if you will see here, notice here, let's take an example. We have received three packets, packet number 1, packet number 2, packet number 3. Maybe your packet number processing is happening here. Maybe packet number 2 is processing here and packet number 3 is processing here. Means all your packet is getting processed parallelly or not? They are getting processed parallelly because Palo Alto Firewall has a Palo Alto hardware as a parallel processing hardware. But if you want to understand in the very efficient way how this parallel processing hardware happens, let's go here and let me just open one more diagram which we have already opened at the starting with this multi-core CPU. Now guys, in this particular diagram, if you will notice, what used to happen in the high-end boxes, because you know your actual high-end boxes like Palo Alto 5000 series, 7000 series, right? They are the boxes who basically the actual SP3 is implemented into these high-end boxes because these boxes they have a multiple data planes. Like 5000 series box, it has a 3 data planes and it has a 2 signature match processors. This, the first one is known as DP0, second one is known as DP2, DP1, and third one is known as DP2. And I'm talking about the architecture of Palo Alto Firewall PA 5060. Now guys, what happens? Let's take an example. We have received a 3 packets, packet 1, packet 2, and packet 3. And now let's suppose your network processor is not involved in that processing. And let's suppose they are the normal SYN packets. And so your SYN packet for SYN packet Jaguar chip will not involved. Maybe what used to happen? See, these particular processor, they are the multi-core processor. Maybe your packet number is processing is happening here, packet 2 is processing here, and packet 3 is processing here. And also there's a maybe one more chance. Let's suppose we have another combination of 3 packets, packet number 4, 5, and 6. Maybe your packet number 4 is processed by the core 1, CPU core 1. Then packet number 2, core 2. Packet number 3, core 3. Because these are the multi-core CPU. And guys, this is a very old box. If you will see for PS 50 to 20 or 5400 series boxes, here we have a 64 core in one CPU. Means this particular CPU can able to perform 64 tasks in one go. This can perform 64 tasks, this can perform 64 tasks. Means it can able to perform 64 packets just in one go. Means all your packet is getting processed in parallel way. This is the parallel processing architecture, guys. This is the actual parallel processing architecture, or this is the parallel processing hardware of your Palo Alto appliances. I hope you got the points here. I hope everyone understood the parallel processing hardware component in your Palo Alto. If you understood, write yes. If no, then write no. So I can put more light on it. Everyone is good with that, guys? Okay. If everyone is understood, then that is okay. Now let's try to understand the See, because this I have already covered, guys, so I will not discuss this again. But now I just wanted to cover your this is also not good. Go back here. PCNSC day one. Now, guys, let's try to understand the. So, like this is the same information which I have just covered, right? These are the stages: ingress stage, flow lookup, session setup, right? Or flow lookup, like then security processing, app ID, content ID, egress, right? And these are the different procedures they have mentioned. Now let's try to understand how you. And also, guys, just remember one thing. See, we have a network processor. Network processor is a session offloader, and here they are using multiple chip like EZ chip, FPGA, and ASIC. Then we have security processor, which is the actual data planes processor. And here they are using KVM processor. So guys, you know this why I have used Octeon, because you know that information available publicly. Tiger I have used here network processor because it is available publicly. But you know, maybe that name they have changed. And instead of Marble and Petrachev, you will see the Qumran, then FE100. These type of names you will see nowadays, but these things I cannot able to discuss here. Okay. Now, so guys, what happens, as I have mentioned, your actual single pass software. It's very slow actually. Yeah. So you know your single pass software, let's try to understand that. Single pass software, we have gone through with the parallel processing hardware. Now what happens, as I have mentioned, your single pass software applicable at content engine for the content ID. And guys, in your Palo Alto firewall, this content identification has happened with the help of signatures. How my firewall get to know there is some type of malicious virus available? Because it has a signature for antivirus. It has a signature for spywares. It has a signature for vulnerabilities. It will perform the app ID because it has a signature database. For URL filtering, it has a database, right? For file blocking, we use it will have a decoders and all who will perform the file blocking and all, right? Or who can basically tell you the file types and all, right? Because it has all these signature database, and even though you can able to also check these signatures. If you will go inside your Palo Alto firewall into objects tab, spyware, signatures, so all signatures. So these are the signatures available. For see, Metaperator is a one of the exploit, right? So it has these Metasploit, Python, Metapredator exploit and all, right? If you will see, it has a signatures of around 8500s. These are the signatures are available. Okay. For vulnerability protection, it has a signature database. See, all these are the signature with regards to vulnerabilities and all. Okay. So now, what used to happen, guys? Palo Alto Firewall uses these signature database, right? So what happens? As I have mentioned, if you will have seen your Jaguar chip, in Jaguar chip we have a RAM, right? So what it will do? Your Octeon chip, or I can write down here data plane CPU, DP CPU. What it will do? It will hand over the layer 7 data, layer 7 payload from your packet towards this Jaguar chip. So what this Jaguar chip will do? It will store that particular data into the RAM at the certain memory locations. Let me just show you that part. So let's take an example. We have a memory locations on the RAM 000, 001, 002, 003, 004, like that. We have these memory locations. Now what happens? We have stored, let's suppose, that layer 7 data into these memory locations from that packet. This is the data or payload. This is a layer 7 payload we have stored. And because on this Jaguar chip, basically all that signatures are available. Let's suppose we have a antivirus signatures here, we have a anti-spyware signatures here, we have a vulnerability protection signatures here, we have a URL database here, we have a wildfire signatures here, we have a file decoders here for file protection, we have all these signatures here. So what they used to do generally, now, because they are stored here, right? This data is stored here. So what they will do now, what will do? See, as I have mentioned, we have a one algorithm called pscan, right? Now this pscan algorithm is available here. Now this pscan algorithm instruct all these particular signature database. So what they will do? They will load that particular data together, and they will process and they will get back with the results. They will come back with the results. Means your data is stored once in the RAM and it gets processed again, antivirus, anti-spyware, vulnerability, URL database, wildfire, file protection together. And the result of that particular inspection is passed to the Octeon chip. Now it's the duty of Octeon chip or the data plane CPU, what he needs to do. If there is any type of threat, means if there is some virus or malware available, what it will do, your data plane CPU will drop the packet and it will change the actions on that packet which is discard. So guys, single pass software applied at content engine, because all these tasks done on the firewall once. It will store that data once and it will get processed. That's it. and we will get the results. So that is known as single pass software. Means your data is passed to the softwares once, means in a single pass, and all these checks happens just in single pass. There is no multi-passing happening. Now let me just show you one more diagram for the multi-pass, so you will get the idea. Even in yesterday's session, I have discussed the multi-pass, but let me show you the architecture of multi-pass. This is the multi-pass architecture. In multi-pass architecture, guys, what used to happen? Let's take an example of Cisco. In Cisco, yesterday I have told you we have a ASA firewall which has a Lina engine. Then we have a snot engine for IPS. Then we have a WSA engine for URL filtering. Then we have a AMP engine for advanced malware protection. What used to happen, guys, on ASA when it received the packet? So your lean engine will process the packet and it will pass this packet to snot engine. A snot engine did the process, it will return the packet to Lina. Then again ASA will pass the packet to URL filtering. Then your packet coming back to Lina, then your packet again go to AMP and your packet come back to ASA, and after that it will go here. Means if you will see by this diagram, packet received, get processed by the firewall Lina engine, then packet return back to Lina engine, then it has basically forwarded to the URL filtering engine. URL filtering engine will process this layer 2 to layer 2 layer 3 task, port or protocol based, then HT decoding, stored on the RAM, process, and it will return back to your ASA, then it is going to IPS, then it is going to AB. So here if you will see multiple tasks is repeatedly happening. But in your Palo Alto 5, what happened? Everything happens just in one go. So that's the benefit of your Palo Alto firewall, because it has a single pass software architecture. And your other vendors device, even the Fortinet and all, they have a serial based architecture. One task, then next task. One task, then next task. That's a serial approach. It's not a parallel approach. Okay. So guys, that is known as single pass software. Or so this is a multi-pass architecture, and whatever we have discussed, that was the single pass software. Okay. Now let me show you one more thing. I need extra 30 minutes, guys, today. Let me just complete one more thing here. And guys, by discussing this, we have completed the SP3 discussion. Now let me just tell you with regards to the block diagram. So as I was mentioning, we used to have interfaces here, right? So let's take an example. I just have a 4 copper ports on my firewall. Okay. And I have a 4, 1, 2, 3, and 4 SFP port. This is Ethernet 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 1 by 7, and 1 by 8. This is my copper ports, and these are my fiber ports or SFP ports. So generally these ports, they have a connectivity. So your copper ports, as I was mentioning, they have a connectivity with the Marvel chip. And your SAP plus ports, they have a connectivity with the Petra chip. They are connected like this. And after that, this particular Petra chip, it has a connectivity with the network processor. And let's say we are having here Tiger chip. A network processor is a FPGA. And it has a connectivity like this. And these links is known as joy links. These are the high speed fiber links. Okay. And now this Tiger chip, it has a connectivity with Octeon chip, which is your DP CPU. Here also we have a joy links. Then this Octeon chip will have a connectivity with the Jaguar chip. In Jaguar chip, we have a AHO and DFA algorithm. And nowadays DFA is replaced with the PS scan. This is also this is your signature match processor. Okay. And it also have a connectivity via joy links. Okay. Now guys, let's try to understand one thing here. Let's take an example. I have one PC here, PC1, and I have one server here. Now this PC have a connectivity on Ethernet 1 by 1, and this server have a connectivity on Ethernet 1 by 7. Let's suppose this is my inside, and let's suppose this is my DMZ. I'm taking this hypothetical connectivity, guys. Okay. Now guys, as I mentioned yesterday, what is the first packet when this PC will communicate with this server? And if this server is hosting the services on 10.1.1.101 on TCP/22, and the IP of this machine is 10.1.1.100. What is the first packet in this communication? TCP SYN packet. So now let's try to understand how this particular SYN packet is processed by the firewall. So guys, what is the normal processing? If I will write down the TCP, let me just use this one, TCP SYN processing. So it will go through with the ingress stage, then your flow lookup, then your silo path, then your fast path, then your forwarding, right? If I write down the second thing, guys, for TCP SYN plus ACK packet or your acknowledgement packet means this particular second and third packet. The processing will start at the ingress stage. then your flow lookup, then your fast path, then your forwarding, right? This is the very simple one. Sumant, you can just watch the yesterday recording. I think you have not understood the concept of stateful inspection actually. Now, so guys, let's try to understand the how firewall or how the packet flow will be there when it will send. So let's say it has sent the very first packet, which is a TCP send packet. So TCP send packet received on Ethernet 1x1 interface, or better to use some this one. So your first packet received here, it will go Ethernet 1x1, it will go to Marvel chip, it will go to Tiger chip, and it will go to Octeon chip. When it will go to into this Octeon chip, now Octeon chip will do all these tasks: Ingress Stage, flow lookup, slow path, fast path, and forwarding. And after that, this particular packet will be processed back towards the server. When this server sends the reply SYN plus ACK packet, when it will basically send the SYN plus ACK packet, and how it will do the processing, your SYN plus ACK packet basically received by the Petra chip, the network processor, then it will go to your Octeon chip. Octeon chip will do Ingress Stage, flow lookup, fast path, forwarding. Why it is doing the fast path? Because connection is already created when he received the first packet, so it will bypass the slow path for subsequent, because it's a reply packet. Then it will basically forward this packet like that. Now we will receive the acknowledgement packet. Will be received from here, right? So let me just draw the acknowledgement packet. We will basically get the acknowledge till the Octeon chip process, and it will basically send this ACK till here. Now guys, let's try to understand the HTTP GET processing. What is the first check it will do in the HTTP GET processing? Ingress Stage, flow lookup, fast path, app ID, content ID, then your forwarding, right? Now how this HTTP GET processing is happening? So your HTTP GET is initiated by this PC. So what he will do, it will initiate that request, and let me use the black color for HTTP GET. So your GET received by the Ethernet 1x1, then Marvel, then Tiger, then Octeon. Now when it will reach that Octeon chip, sure your Ingress Stage, flow lookup, fast path, these three tasks done by this chip. And after that, for app ID and content ID, it will hand over this layer 7 content to Jaguar chip. Jaguar chip will do the app identification and the content inspection with the help of AHO and DFA algorithm, and it will use the signature database for that, and it will return that particular results to the data plane CPU or the Octeon chip. Now Octeon chip will do the forwarding. It will forward that packet through like this till the server. So that's how your packet processing is happening according to the data path of your Palo Alto. Same goes to subsequent request and reply packets. Now let's try to understand one more thing. So guys, till TCP SYN, SYN plus ACK, then ACK, then HTTP GET. I think things are clear, right? No. So as I was mentioning, HTTP GET request initiate from here, right? So how HTTP GET will be there? Your GET received at Ethernet 1x1 interface. Then it will go to Marvel chip, then Tiger, then Octeon. Octeon chip will do Ingress Stage, flow lookup, fast path. And for app ID and content, it will hand over that packet here. It will do the app identity and content identification and return back that results to this chip. And after this Octeon chip will do the data forwarding till here. Now guys, this is the communication till HTTP GET request. Now let's me just take one more example here. Let's suppose your session is offloaded. Let's take an example. Your session is offloaded. Now how do your offloaded session will be processed? Because you have some doubts on offloading, so let me just cover that as well. In offloading, what used to happen? Let's suppose your offloading is started from packet number 20 onwards, and we have received packet number 21 from here. So let's say it's a packet number 21. So this packet reaches to Marvel chip. Marvel chip will forward to Tiger chip, and now this Tiger chip will do the Ingress processing. It will do the flow lookup. Then it will do the fast path and your forwarding. These are the tasks done by the network processor, and your packet will be go back from here. And it is not even though reaching till this Octeon chip, because we have offloaded the load from this particular chip, because this is the main chip who will do the this is the main chip which performs your packet processing. So to offload the load from this chip, we have added this extra chip, and this particular device this particular chip act as a network offloader, because it has a capability of reading layer 2 to layer 4 data. Now you may ask one thing, how it will do the flow lookup? But because flow lookup is a part of Octeon chip. So guys, it will not perform flow lookup because network processor is not capable of doing the flow lookup. Then how you can say how they will manage the session timeout? How they are able to manage the session timeout, right? So to manage the session timeout, what they have to do, after exchanging 16 packets, once 16 packet he will receive from any direction, it will just send one message to Octeon chip. There is a traffic. So 16 messages for low end boxes, and if you are working with 70,000 series box, then there is a 64 packets. After receiving 64 packets, it will send this particular message to Octeon chip, because your Azure process who will maintain the timeout of your sessions is running in the Octeon chip, because session management done here, right? So it will basically inform this tip. So here we have the ingress stage, flow look, fast path, and forwarding. No flow lookup. It will just count the packets, how many packets he has processed, and after that it will basically update regarding these packets to Octeon chip. This is the session offloading, and that's how your session offloading work. And your session offloading only applicable for the packets, for them layers when processing is not needed. Layer 7 processing not needed. And why layer 7 processing is not needed? Because let's take an example. We are receiving encrypted packets. And there is no SSL decryption we have not configured. SSL decryption we have not configured on the firewall. So there is no any sense to send that packet here to your Jaguar chip, because it will not able to give you the results. It will not able to scan. It will not able to perform the deep packet inspection because data is encrypted. So what in that case, this chip will basically send one message, layer 7 processing is completed. And once it will send that particular message to Octeon chip, now Octeon chip is ready to offload that session. And you know, this particular processor is not available into all the devices, all the Palo Alto vendors. This network processor you will see on 3200 series boxes, 3400 series boxes, 5200 series boxes, 5400 series boxes, and 7000 series boxes. And you know, this offloading, if you want, you can also able to disable it. It's up at this particular setting, you can disable as well if you don't want. Okay. So guys, this is the block diagram, and that's how the traffic flow happens at the hardware level inside your Palo Alto firewall. So that's it, which I wanted to cover. Sarup, you are asking repeated questions actually. What I have told you, what is the criteria to offload the sessions? What is the first criteria to offload the session? It will offload the session. For them, content inspection is not needed, right? If there is a content inspection, then this session it will not offload. Now, guys, generally how you will get the initial access of your firewall in your organization? This is the most important topic. So guys, what used to happen generally in your organization? What you used to receive a fresh box sometime? Maybe you have received a fresh box or a new box. Now you have to basically do the configuration on this device, right? Or maybe you have some of the old device in your data center, in your warehouse, right? And you want to basically log in into that device, but you forget the login credential and all, right? So these are the things I will cover here. So guys, to get the initial access of the firewall, the very first way, which is always recommended, connect your firewall with the console cable. Connect your firewall with the console cable and you will get the CLI access of your firewall. Once you will get the access of your firewall via console access, configure the management interface. And you know, when you will connect with the console cable, you have to basically log in into your firewall. So the default username in your Palo Alto firewall is admin, and default password on your Palo Alto firewall is also admin. So this is the default username and password. And guys, this question they will ask you in the interview: what is the default username and password in your Palo Alto firewall management? Or what is the default password of your Palo Alto firewall? And guys, by default, this management interface will also have one IP address, which is 192.168.1.1/24. This IP address by default configured in the Palo Alto firewall management interface. Just remember. Now, guys, see, let's take an example. You are having one of the router in your infrastructure, and on that router, it's a edge router, and all your users, they will forwarding the traffic towards this router on this IP address. And if you have connected the management interface of this firewall with one of the switch, then what will happen? All the traffic, instead of going towards the router, it will start going towards the firewall management interface. So just make sure whenever you will connect with the console cable, modify the default password, which is admin, and also configure the IP address on the management interface. Configure the IP address, subnet mask, and default gateway. These are the three things which you have to configure. Okay. And guys, why we are configuring this management interface of your firewall? So we can able to get the dedicated out of band management, OBV connection, out of band management. Okay. Default IP address is 192.168.1.1. In the VM series firewalls, we have a DHCP client option is enabled. So you will get the IP address via DHCP server if you are having any. And remember one thing, we never configure the IP address from DHCP here because we always want static IP on the firewall management interface. Now, you can connect the console cable like this. You can connect the management port. And whenever you will basically log in first time in your box, always run this command. So system info. Why you have to run this command? So you will get the what is the host name of your device, what is the serial number of your device, what is the operating system you are running, what are the dynamic updates. Check all these details. Check the DNS details and all, right? So if I will run this command, let me show you the output. Show system info. Run this command and check the data. You will get the IP address, host name, netmask, default gateway, IP assignment, MAC address. Why MAC address is important, guys? This MAC address you can use for tracking. You have connected your firewall management port with this right switch interface. Because in production environment, let's suppose you are doing the config remotely. You have sent the field engineer at the location. Maybe that field engineer by mistake connected the port, connected this per firewall management interface on the port 20. But as per your design, you want to connect on port 30, right? So to avoid such type of mistakes, track from on which port you are basically learning that particular MAC address on the switch. You will get the model number, then serial number. This serial number we need to register your firewall with the support portal, because to activate the license on your Palo Alto firewall, we need to log into the support portal and we have to do everything from there. Okay, just remember. Now guys, this Palo Alto firewall, you can able to control or you can able to manage, means you can able to configure by using 4 methods. Either you can access using the web interface, so you will get the GUI access. You can also able to control with the help of Panorama. You can also able to take the CLI access using SHS or console, and you can also able to control with the help of REST APIs or the XML APIs, means the automation. Okay, means now to get the GUI access of your firewall using the management interface, you have to basically connect using the HTTPS, because by default on your management interface, HTTPS, SHS, and ping, these 3 services is enabled. It's up to you if you want to enable telnet and HTTP, but it's not recommended at all. By default, HTTPS, ping, and SHS is enabled in your Palo Alto Firewall management interface, so you can easily communicate with the management IP address of your firewall. Whenever you will connect, you will basically able to get, you can log in on your firewall. Initially, it will basically prompt you to change the password, so you have to change the password, and this thing we will see practically as well. Now guys, remember one thing, when you will see this particular box, it has such type of details. It has these copper ports. These are the Ethernet ports 1 to 12. Then you have a SAP and SAP plus ports, 13 to 20. Then you have QSAP ports, HSCI ports you are having, and guys, these HSCI ports generally people use as a HA2 interface because firewall always deployed as a active passive HA. Active will be there, but people don't use active. Active passive is the recommended one. Then you will see HA1 and HA1A and HA1B on the high end boxes. Then you have a management port, you have a console port, you have a USB port, so you can connect your USB drives, console port micro USB. So this one, you can also nowadays connect with the firewall using this particular type C type of connector. If you have a console cable with that, then you will get some LEDs and all. Okay, so guys, these are the details you have to know with regards to your Palo Alto firewall. So one more time, let me just repeat. In your Palo Alto firewall, default IP address on the management interface is 192.168.1.1 and subnet is /24. This is for hardware boxes. On VM series boxes, there is a DSCP option is enabled. Means it will get the IP address from DSCP. Default username is admin and default password is also admin. By default, ping, SHS and HTTPS is enabled on your Palo Alto firewall management interface. And the first time we will get the access of your firewall via the console cable. Once we have the console access, then we will basically configure the management port and we will get the access. There is a one more way. You can directly connect. This is the management. You can connect your PC directly with the cable with this firewall. As we know, Palo Alto Firewall having default IP address into this CD. So configure the IP address in your PC, which is 192.168.1.10/24. And your PC and your firewall interface are in same subnet. So you can also able to access the firewall GUI, SHS, and ping. Okay. And guys, it is always recommended from the Palo Alto site in your management interface, it must have the static IP address on the management port. There are the multiple regions. Maybe you have created the certificate to secure you are using your certificate to secure the web or GUI communication. Maybe your firewall needs to communicate with the LDAP server or with the syslog server, or maybe that traffic is going through one of your data center firewall, because these syslog servers, your LDAP server and all behind that data center, right? So you have to allow that particular IP into that firewall as well. So it is always recommended go with the static IP. If you are not going with that, then your design is not optimal. So guys, these are the things which I just wanted to discuss with regards to the initial access. And that's how we have completed our day 1 and day 2, guys.